Douwe studied philosophy and received his PhD in computer science from the University of Cambridge. He was a research scientist at Facebook AI Research, head of research at Hugging Face, and now runs his own startup called Contextual AI. And if that wasn't enough, he is also an adjunct professor at Stanford University. Welcome.
Yeah, thanks. Great to be here. Thanks, everyone, for coming.
Now, I mentioned that you run your own startup, Contextual AI. What exactly do you do there?
Yeah, so at Contextual, we're really starting from the observation that language models are really amazing new technology, but it's also just first-generation technology. So if you look at where we are right now, we're sort of trying to discover what the use cases are, but there are a couple of really big problems with language models. And these are very familiar issues, things like hallucination, so they make up information that doesn't really exist or that isn't true.
Can you give an example?
So you can just ask the language model, like, I don't know, what is the capital of something, and it might just like make some stuff up. It's not necessarily grounded in real, like, ground truth information. So what you really want to do is you want to have attribution where you can point back to the source and say, like, this is my answer, and I gave this answer because I found it here, right? Doing this is called Retrieval-Augmented generation. It's something that I pioneered with my team at Facebook AI Research in 2020. So everybody's using this right now, which is really great for me, but the paper's from 2020, so we already know that you can actually do a lot better than this old RAG 1.0, and that's what we're building at Contextual. It's sort of RAG 2.0.
Good. So you already mentioned a few challenges there are in the realm. We will dive deeper into that. But before we go to that, let's talk about the data sets. You know, that are basically data is the lifeblood of AI. Can you explain a little bit why that is so important?
Yeah, data is hugely important. I've been saying this for many years, and people were kind of ignoring it, and it was all. So in AI, I think data is considered less sexy than algorithms or models or like compute and things like that. But without data, you're really nowhere. So I think in the big data days, people were saying that data is sort of the new gold. But I would say for AI, data is really like oxygen, right? Like without it, like these systems cannot do anything. So if you want to build state-of-the-art AI systems, you basically need three things. So this really powers the entire revolution right now. So we have algorithms, basically like neural networks, transformer architecture. Then you need a lot of compute, so GPUs. You want to maximize your flops, your floating point operations per second, so your calculations, basically. And then the final part is data. So the data is really kind of the secret sauce for a lot of this stuff, because algorithms, everybody knows what the algorithms are. This is all completely public, right? It's just scientific research. Compute, you can just buy. Right? That's why NVIDIA stock is doing so well. You can just buy a lot of compute. But data is really hard to get, really high quality data. And if you look at like OpenAI, I would say that this really is their superpower, much more than everything else. It's just about the data.
And you were mentioning the quality of data. I mean, this is key. I mean, data is not data. It depends a little bit. What are the challenges of existing data sets?
Yeah, so I think you can unpack it in different ways, but so I think it might be useful. So this session is also about how to train your AI, right? So if you look at how to train like ChatGPT, it's basically three steps that you need to do. So one is you need to pre-train a very large model on a very large corpus of web data. So this is just like from the internet, basically. You have
just crawl the whole internet.
Exactly. And so you can curate the data from different sources too. So this could give you an edge, actually, if you know where to get cleaner data. But that's step one. So now you have a pre-trained base model, as we call it. So then the next step is you need to instruction fine-tune that base model so that you essentially fix the natural language interface. So the base model is terrible at following instructions, because instructions don't really happen on internet data, right? So you have to first do that. And then the final step is alignment with human feedback. So you really want to do what we call RLHF, reinforcement learning from human feedback, so that you can get the system to be better aligned with what human expectations are. So for every one of these steps, you have different data, and every different type of data has different challenges associated with them.
So are you talking about a feedback loop? Is that what you're referring
so the
to?
last part is a feedback loop,
okay.
Reinforcement learning from human feedback. But so a lot of the the gold that places like OpenAI, or the oxygen that places like OpenAI have, is really in this feedback loop. So they have a lot of real world usage, which is very different from sort of synthetic data. It's like real humans giving you feedback about what the system is supposed to do. And it's the same for the instruction fine-tuning data. So there's really a lot of secret sauce there. And then I think that a lot of the issues right now with AI deployment, so the real challenges come from the pre-training data, because that's really the base for everything, right? So there the issues are around like bias, ethical issues, copyright is a very big prominent problem now. There's all kinds of issues with evaluation. So yeah, we can talk about all of those.
Yeah, absolutely. So if you crawl the whole internet, I mean, it's human-produced data, and humans are biased. So in the end, what the AI does out of it might be biased as well. So how can we solve an issue like that?
Yeah, it's a huge problem. So it's not a new problem. I think it's really been a problem for a long time in natural language processing in general, in NLP, where if you look at like sentence completions, like the doctor did this, and then you try to see if it's a he or a she that the language model predicts next, it almost always predicts he for the doctor and she for a nurse, and it shouldn't, right? So there are ways to deal with that, but it's just the fact that these language models are a reflection of the data. So one of the things people often say is garbage in, garbage out, right? So if the data that goes into it is bad, there isn't that much you can do. But there are a couple of things you can do. So one is data augmentation. Which means making the data better synthetically. So you take the source data and now you say, okay, every time there's the doctor blah, 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 he, then you also add an example where it's the doctor blah, 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 she, so that the system learns that actually doesn't matter, right? That is, it can be both. So that's one way. And then the other thing you can do is using this ROHF alignment idea. So AI alignment, as we call it in the field, is really about trying to get these systems to do the things that humans expect. And a big part of that is overcoming biases. So if you really train the system to say you should be helpful and harmless and unbiased and honest and all these, you can just tell it what it needs to do and it will behave accordingly.
Okay. So another issue that you raised was the copyright issue, because let's take ChatGPT, for instance. If I want to, let's say, write a poem, it might get inspiration from other authors, and I might not know the source. And there have been authors that sued ChatGPT or other companies. But I think you mentioned, you alluded to it in the beginning, you have a solution to that.
Yeah, so I think this is a big problem because the original creators of the data also need to sort of be rewarded, right? So if you think about journalists or you know, a lot of content, especially high quality content, people put a lot of blood, sweat, and tears into that, and now it just ends up in a language model which is kind of taking credit for all their hard work, but it's not really like passing on the royalties, if you will. So there are ways to solve that, so we talked about retrieval-augmented generation. I think that's one way to do it, where you really, basically you can train the whole system on non-copyrighted data, and then you can give it access to copyrighted data, but now you have this attribution where you can say, I generated this poem in this way because I used 50% of Shakespeare and 20% of this poet. So you can actually assign credit back to the original sources. That's one of the beauties of RAG, I think.
And then also thinking, right now the internet is mostly full of human-produced data, but as we are using more these AI tools, it's going to be filled up with artificially created text.
Yes.
So can AI be trained on data that has been produced by AI? I mean, in the end, it will.
So it can be trained on the data. The question is, does it actually work if you do that? I think that's really one of the big open questions of our time right now. So we don't really know what happens. There are a couple of papers that have initial results that show that everything completely breaks down, but I suspect that paper is a little bit biased. So
why?
I don't know. When I read the paper, it feels like they kind of set off to prove this exact point. So I definitely think there are ways to fix this, where you just have language models learning from language models. And if you're aware of the language model that created the original data that you're learning from, then you just have lots of conversations basically between language models.
Yeah.
And sometimes there can be humans in that conversation too. Right? So the language models are not going to invent their own language, which is one of the risks otherwise. And then everybody learns from everybody.
Another thing that you mentioned was synthetic data. So, so basically, to erase biases, you could add additional synthetic data. Can you tell us a little bit what challenges there are or what opportunities there are?
Yeah, so synthetic data, you can use language models to generate examples to train other language models or to train the language model itself further. So this is a very active area of study right now where, for example, this instruction following part I mentioned, where you want these systems to be able to follow the instructions, and you need to come up with very good instructions for it to learn what to do. And so those instructions you can generate with other language models and then train this new language model on top of that.
Then maybe to come back to your company, Contextual AI, you already also spoke a little bit about how you want to address the challenges there are. What else are you doing to address the challenges with data sets?
What else? Yeah.
And to train the AI.
Yeah. So I think one of my pet peeves. So we're doing this at Contextual, but I think it's a much broader issue in the field is around evaluation. So what we need to get much better at is understanding the shortcomings of systems. So we have these AI models, they're great, but they are also very flawed. And often they're flawed in very unexpected ways. Right? So one of the things I always find very interesting is that it's a computer. There's like a sound issue, no?
Do you hear it well, or are there some sound issues?
Okay.
Okay.
On our monitors, there's some dropping thing. So when we interact with a computer, you expect it to be very good at like mathematics, right? But so language models are terrible at mathematics because they're really not trained that way, right? It's a statistical model. It's not supposed to be symbolic. So that's just one example of the kind of failure modes that are unintuitive to people when they interact with these systems. So what we need to get much better at is evaluating the systems in real-world settings, not just by looking at how accurate they are, but looking at how robust they are, including to things like if I change the gender, it shouldn't really change the prediction, right? Or if I change the name, everything should really stay the same. But these models are often very brittle, so that actually doesn't happen. So if we can measure our systems much more holistically, looking at accuracy, but also speed and cost and fairness and robustness and all these different parts that matter for real system deployment, then I think we can also understand much better what kind of data needs to go into the system to make it better. So from the measurement, you get like a better feedback loop, essentially.
Is it realistic that we will achieve perfection in a data set creation?
No. So I think this whole idea of perfection is basically ill-defined, right? Like, there is no perfect human. So it kind of depends on the training data that goes into humans, I guess, too. So these systems will always be imperfect in their own ways, and just like humans, they will also just be reflections of the data they've been trained on.
Then AI models, they need to adapt to various contexts and purposes. So how does the adaptability of AI models relate to the quality and specificity of the data sets that are used in the training?
Yeah, that's a great question. I actually think that so there's a much broader topic there around artificial general intelligence, right? So there's this idea that we're going to have like one super smart AI system that's going to like take over the world, if you listen to some people. And I think it's an interesting goal to set if you want to have a general purpose assistant for consumer use case, right? So this is basically what ChatGPT is. You just have this AI model. It needs to be able to do everything as a part of its conversational flow. But I think if you look at a lot of enterprise use cases, you don't need that, right? So if you have a system that needs to recommend credit cards to your customers, that system doesn't need to know about Shakespeare or quantum mechanics, right?
Maybe it's even harming.
So that could actually, yeah, it could put it on the wrong foot and you ask it a question and it thinks you mean something else. But so you really want to put guardrails in place on these systems to make sure that they do exactly what you want them to do and nothing else. So I would argue for a lot of enterprise use cases, what you want to have is artificial specialized intelligence rather than artificial general intelligence. And so if you want to do that specialization, you can get much better cost-quality trade-offs, so you can have smaller models, and they're trained on their own specific data sets for their own specific use cases.
Then before backstage, we were talking about open sourced data, AI, whatever. There's so many different spectrums of being open sourced and closed sourced. What would you advocate for, and why?
So I'm a big fan of open source. Like my whole career, I've tried to open source everything, but if you want to run a company, you also cannot open source everything necessarily. So you have to be judicious and careful with what you open source. I think there are different parts to the open sourcing process, right? So you can write a paper that describes your idea, so this kind of open science. You can be open source, so you can say if you want to reproduce the numbers in my paper, this is the code you need to run to get there. And then the final part is open data, where you say if you run this code on this data, then you get the results in this paper. And different places have different things that they open source, right? So if you look at Meta with the Llama language models, they didn't open source the data because they would probably be afraid of getting sued for copyright reasons. But they did release the model, but not the training code for the model, just the inference code for the model. And then there's a research paper that has a lot of details in there, but it's also missing out on some crucial details around the data again. So there's just different versions of it. I think one of the biggest data sets right now is an open source reproduction of the Llama data set. It's called Red Pajama, so Llama Red Pajama, right? So if you want to train your own language model right now, you could just take Red Pajama v2, it's 30 trillion tokens. It's a huge, huge data set, and you could train your own language model on that tomorrow. The question is, how good is that model going to be?
Then let's talk about how we all together can collaborate to actually improve the quality and all the challenges, overcome the challenges. How can industry players that are maybe here in the room collaborate to collectively address the limitation of the existing data sets and contribute to the better creation?
Yeah, so I think open source is really the right way to do that. So I think the way to think about that is like a rising tide lifts all boats, right? I still think that it's very early days in AI. It might not feel like that if you've been in the field for a long time like me, or if you're just getting into it and you're like, whoa, look at all of this stuff that's already been done. But it's still very early days. So the open source community is going to keep growing, I think. And it's going to be very helpful for keeping these very powerful few players in check a little bit and developing useful technology on top to make sure that systems are less biased or that they have appropriate guardrails and things like that. And the other thing I think we can use a lot more of in AI is folks with background in the humanities. Right? So
like you.
Originally, yeah. So I kind of switched away from that, but originally as a philosopher by training, yeah. So I think people from the humanities, they have a very different understanding of the technology as a user. And so if we can get those folks to work together with technologists, I think we get a technology out of that that's going to be the most beneficial for all of humankind.
So a bit more interdisciplinary.
Exactly, yeah.
Okay. Then you said it's a very young field, and I know that you think that we shouldn't regulate too much.
Yes, I'm very against regulation. I think that's really one of the issues that we have in Europe, actually. So I'm a European, but I live in the US, so I sort of understand both sides. But I think the European Union tends to be very eager in over-regulating markets and basically killing a lot of innovation in the process. So I think the Americans are much better at that, unfortunately.
And it's not dangerous if we don't regulate?
So I do think we need to regulate some parts, but if the regulation stems from some sort of fear about like AI destroying the world or things like that, then I think you really don't understand what's going on in AI. So there are real issues, we talked about them, right? Like things like biases and lack of evaluation, so that you don't really understand how you can use these systems safely or what their shortcomings are. So we definitely need a little bit of regulation, but if you start out with over-regulating it and just killing a lot of things and basically just saying, here, Google, Microsoft, OpenAI, very rich companies, this is your market now because it's going to be so regulated that you need to hire like 100 lawyers to even make sense of all this regulation. I think that's a very bad thing.
Well, as we're almost at the end, I brought my crystal ball here, so let's take a look into the future. What trends do you foresee in the realm of AI training, especially concerning data sets improvement?
Yeah, so besides retrieval augmentation, which is sort of my thing, right? The other thing that I think is going to be really big, and you're already seeing that happening now, is multimodality. So these systems right now, they're just trained on lots of text, which is inefficient because there's a lot of higher bandwidth data out there on the internet, right? So if I want to understand as an AI system what the meaning is of the word cat, I can go to Wikipedia and I can read up on cats and see that they're small domesticated carnivorous mammals that people like to use as pets. That's the Wikipedia definition. Or I can go to YouTube and I can watch lots of cat videos, and now I really understand what a cat means to a human, right? So I think if you make use of all of this multimodal data that's out there on the internet that is super rich and a good reflection of the human world, then AI systems will also understand humans much better, and that will be beneficial for everyone.
Great. Douwe, thank you very much for these insights. And now, if you're interested in hearing more on the next generation of language models, RAG that you mentioned, Douwe will be speaking this afternoon at 3:05, so 5 p.m. on the stage 4 in Pavilion 1. So don't miss that session. Thank you very much, and have a good rest of the day. Thank you.